I haven't heard a proposal yet. I wouldn't be surprised if somebody, and I think one of the questions will be, do we want to explore more objects, or do we want to close in and focus on a few particular objects like Pluto? I mean, would a Makemake or Eris, would those be some of the other big Kuiper belt objects that, or some of them are almost dwarf planets or are dwarf planets? I don't have the scorecard in my hand. Do we want to visit those and see more about them? Do we want to do a grand tour of the outer solar system? And from a practical standpoint, how are you going to have a PI of a mission that lasts 200 years? So, there's some, practical level things to that issue. I would think it would be, I think actually where it probably is a little bit down, where we've got Juno orbiting Jupiter right now. There are, I believe there are people developing plans for Titan mission. There's been talk of a Europa mission, I believe. There's talk of a number of things. It's going to be a matter of finding some priorities. If we can get there, if Bill Gates decides he's going to give all his money away to explore space, and with robots, let's say, how would that work? I think we probably see some sort of new technology, new exploration technology ideas. But one idea that's come out that I think has some interesting possibilities is the proposal to send a fleet of little, very small spacecraft, smartphone-grade spacecraft that would be laser-powered out of the inner solar system and on its way to Alpha Centauri. Now, one of the interesting questions I heard somebody ask is, well, wait a minute, how do you stop it at Alpha Centauri? I don't know the answer to that. But if you could use some ideas like that, some technologies like that, or some other innovative ideas, let's say you could take microsatellites or microprobes and send a small fleet of them orbit out to Pluto, so that they could be with maybe each would have a different instrument that would be exploring. Maybe you had something to land on Pluto. You would want you would want to get out there reasonably fast, but not so fast that you don't have to take a ton of rocket fuel to slow you down. There's a lot of interesting logistic questions to do that. And it would take, you probably could work out some of the realities of the paper. I think you're sadly right that most of us are not going to be around to see that. But we've got a lot of really interesting ideas. We've got, there's schemes. I don't know that this is any official proposal, but one Stanford professor I was talking about essentially a kilometer array of optical telescopes in orbit that would be have a resolution of a 1 kilometer telescope at an optical wavelength, so you give really high resolution for looking at exoplanets. And of course, you return that at Jupiter, at Pluto as well. You get reasonable amounts of light from Pluto. You could do that to some of the other Kuiper belt objects. How much can you do with sensors going out there? There's a lot of new electronic technology and electro-optic technology that can be used for exploration. We don't have to send people out there. We can send very, very capable robots. And
It's always, I mean, one of the biggest things is changing, that makes a lot of things possible, is simply that we're getting smaller and smaller rovers. And like can't remember, how big is the Jupiter, the Pluto probe? I think they remember things like the size of a Volkswagen or something.
It's something on that order.
But what's today, or say within the next 20 years, might be the smallest thing we could send that would have exactly the same capability, or maybe a lot more. You know, that the payloads can get more and more useful because of the computer miniaturization, not because of advances in rocket science.
Well, you get electronics, computer miniaturization. You do need, for good high-resolution optical observations, you need, there is a fundamental physical limit that comes from how large an aperture you're looking from. But you don't have to make that a solid glass mirror. You can have an array of little thin mirrors that you somehow fix so that they fit the idea of the kilometer space telescope, because you have little things that are all fixed in relationship to each other. You have laser interferometers going between them and keeping them very precisely aligned with each other.
So the optics would be the factor that put the limit on how small you can make things?
Well, the optics will put the optics. Basically, you'll have to use some innovation to get high resolution. There's some certain things there, but the resolution is one thing. The wavelength range you want to see is another. You can probably see some interesting things as you go far out into the infrared, because you look at the part of the spectrum, the black body spectrum, where you go out to something as 50 degrees Kelvin. That'll be probably 30 microns or something like that, and 50 microns. And I'm making those numbers up, but it's just, I don't remember the exact point relationship.
Let's get a little more science fictional. At some point, when do you think you're for the possibility of sending something out that can actually construct the instruments you want from the materials in the Kuiper belt?
That would be intriguing. Give us 50 years.
I think 50 years.
No, I don't mind.
I think that's probably, I was...
Putting it in.
And we have 5 minutes.
5 minutes, okay, thanks. And this is one of the things, the future, as Yogi Berra would say, is always hard to predict.
It's hard.
But that is within the realm of possibility.
I think we're talking about the realm of possibility. I mean, we're talking here, we know how to send robots into space. They don't die as easily as humans do in space. We've got tremendously powerful tools for transmitting information. The technology for using lasers to transmit, from Mars is available. And if you get out to Pluto, you can, you would have to have some sort of energy, radioactive energy source or something like that to power it. But you could send, collect a lot of information, send it back to Earth, do some processing out there, depending on how well the electronics work at those temperatures. There's a lot you can do. If you go back 50 years, and I'm old enough to remember, 50 years ago, or 50 years ago, Pluto was a spot in the sky. Little tiny dot. Nobody knew what it was. There was no telescope in the world that was holding it. There was just even more than a fuzzy dot. That's 50 years ago. Another 50 years, we could have things hovering out around Pluto, reconnaissancing, seeing the weather on Pluto. I mean, it probably wouldn't be really exciting, but we don't know. That's the fun thing about this. We don't know. This is in fact, I was talking with somebody today about dark matter, a completely different topic, and we've been looking for dark matter for about 20 years now. And there are people interested in looking at is to say that the people have suggested that the black holes that LIGO saw, the laser gravity wave source, that those black holes might be dark matter. But you know what? The other interesting point about that is Einstein predicted the gravitational wave just about 100 years ago. It took us we took about 100 years to detect that prediction. You know, we're getting better than that. You know, it takes a long time to develop instrumentation that way. But you know, we're getting tremendously powerful instrumentation. You know, beyond the dreams of people 50 years ago. You know, how could you? Nobody. I couldn't imagine 50 years ago having a telescope that would show us a planet orbiting another star.
But now we can, yes.
Yeah.
We can, in fact, we have a good idea about what it will be like, right? The size.
Yeah, we've got seen. There's actually, we can see young planets around the stars because they're relatively hot in the infrared.
Well, that's right. Yeah, yes, sir.
So that we can actually see them. So it's just amazing. Any more questions?
Hey, I'm the leader. I'm supposed to ask.
Okay.
Any more questions?
Not so much a question, but a couple points. We are seeing an addition to the Europa lander. It's going to take off in 2022. 175 million have already been slated for that. If people want to learn more about what we're doing robotically out in our solar system, or even the inner solar system, well, the best sites out there is one that's not run by NASA or anything. It's called unmannedspaceflight.com.
Oh.
And it is, anybody can contribute there, but an awful lot of mission people who are actually running these things are active contributors to that site. It's basically a series of reports. And I followed, I've been following Mars missions and Pluto is on the extreme detail of those. And the people there really know their stuff. Unmannedspaceflight.com.
Unmannedspaceflight.com.
Yeah, I just wrote that down. Thank you.
I'm trying to, but I'm not quite as well organized. No, I've got my.
Okay, you've got it. So, all right, we're being shot.
We're done now.
We're done, but thank you all.